Today here we will discuss how to check the injectivity of a function. For that we will be discussing three ways. First way is by definition, which says if f of x1 equal to f of x2 implies x1 equal to x2, and second way is by pictorially, where we will use arrow diagram, right? And then third way is the horizontal line test. Okay, also there are ways, say with the help of differential coefficient we can check injectivity of a function about which we are not discussing here now, right? Let us observe all these three ways through solving a question. Here is our question. If f is a function from R to R, a real set of real numbers, which is defined as fx equal to mod of x, is it 1 1 and on 2? So here we have to check injectivity and surjectivity of the function. But checking of surjectivity, let's keep it for later occasion, and now we will be checking injectivity only. Okay, so let's get started. Here our function is defined on the set of real numbers, so we can consider any number for the values of x. Hence let us find the values of f of x1 and f of x2, taking x is equal to 1 and x2 is equal to minus 1. Therefore f of x1 equal to f of 1 equal to modulus of 1, which is equal to 1, and f of x2 equal to f of minus 1 equal to modulus of minus 1 equal to 1, which shows that f of x1 equal to f of x2, which is equal to 1, but here x1 is not equal to x2, as 1 cannot be equal to minus 1. This shows that f of x is equal to modulus of x is not 1 1 function. Here we checked the injectivity of the function by definition. Okay, this is our first way. Now let's move to the second way, where we will use diagram. This is our diagram. Here we are using two elements such as 1 and minus 1 only, though our given sets are of real numbers. Definitely there are uncountable numbers of numbers, but for our convenience we will be using only these two elements. Okay, now let us write our function in roster form, and then we will depict it by arrow diagram, right? In roster form, r can be written as 1 comma 1 first ordered pair and the minus 1 comma 1 second ordered pair, and so on. Here we are writing only two pairs, though there are many more pairs, right? Let us represent these in arrow diagram, which clearly shows us that one element in codomain is related to more than one element in domain. That is, function is not 1 1. Now we will check the injectivity by a horizontal line test, which says that in this test we draw a horizontal line parallel to x-axis intersecting the graph. If the line intersects the graph more than once, then the graph is not 1 1, otherwise the graph is 1 1. For that, let us have the graph and we draw the horizontal line which intersects our graph at more than 1 points. This is clearly we have seen in our picture. This is telling us that the function is not 1 1, isn't it? Okay, thank you.